Hello and welcome to another session in physics. In this session we'll be looking at the topic friction. But before that, let us review the previous lesson. Welcome back. Now let's take the definition of friction. Let's see what we mean by the term friction. Well, friction has been defined a force which acts at the surface of separation between two objects or two bodies that are in contact with each other and they tend to oppose each other's motion. Let's say this is a table, for instance, and there is a ball on top of this table. Of course, there will be friction at this point of contact between these two objects that are trying to oppose each other's motion. And that's why you have to move your hand freely over a desk, because your hand, the palm of your hand and the desk are simply in opposition to each other. They're trying to stop each other from moving. So we say friction is simply the force of opposition. It is a force that opposes motion. We have two basic types of friction. The first one is static friction, given as Fs. The next one is dynamic friction, given as Fp. It's always important for you to know that static friction is greater than dynamic friction. So as you can see from the graphical representation here, you see that if there is a pushing force and there is a motion existing between two surfaces in contact with each other, there is bound to be friction existing at the point of contact between two of them. We have laws that govern solid friction, and we have about 5 of them. Now let's take them one after the other. The first one is that friction opposes the relative motion of two surfaces in contact. That is the first law. When you hear friction, the first thing that should come to your mind is opposition or opposing force, something that stops one from happening. The second law of solid friction is that it is independent of the area of the surface of contact. Yes, it does not have anything to do with the area of the surface of contact. It does not depend on the area of the surface of contact. The third law is that it depends on the nature of the surface. Yes, friction has a lot to do with the nature of the two surfaces in contact. So if one surface is weak and the other is smooth, of course it's going to create a special kind of movement between two of them. And if both surfaces are smooth, of course you know that it's going to cause gliding, like there will be easier movement between the two surfaces in contact. The fourth law of solid friction is that it is proportional to the normal reaction. We'll see that in the diagram that will soon follow. And the fifth law of solid friction is that it is independent of relative velocity between the surfaces in contact. And for that reason, we say that friction is directly proportional to the normal reaction. What it simply means that friction is equal to this and then R, where this is our coefficient of friction. As you can see on the slide here, it's known as our coefficient of friction. It is, when we try to make it the subject of the formula, it's going to become the ratio of the frictional force to the normal reaction. That gives us the coefficient of friction. Y is our normal reaction between the two surfaces in contact. As you can see from the diagram here, you would see that normal force, so normal reaction, is always perpendicular to the surface that an object is on. So this is normal force. It is perpendicular to the surface that an object is on. Notice too that the normal force, which is R, is also the same thing as the weight of the body. And we both know from our study of weight and mass that the relationship between weight and mass is that weight is equal to mass times acceleration due to gravity. So therefore we say that R is equal to W, which means that R is equal to mg, as you can see from the slide here. Therefore our F is also going to give us coefficient of friction times the mass, product of the mass and acceleration due of that body. Now, let's look at some different kinds of cases when the force of friction is applied. The case 1 is that if a force is applied and an object refuses to move, an object is stationary. It is given by the force minus the frictional force, which is equal to mass times acceleration. Because since there is no motion, it simply means the body is not accelerating, and when the body is not accelerating, we say A is equal to 0, which means minus frictional force is going to be equal to 0. That is case 1. Case 2 is when a force is applied and the body moves. So we say the force minus the frictional force gives us mass times acceleration, but this time around, because the body has moved, the force now becomes frictional force plus mass times acceleration. So it's not going to give us 0 at all, because acceleration equals 1. The body moves. Now, what if a body is moving at an angle, and not in a straight line? As you can see from the diagram here, you notice things like normal reaction. This instrument is called an inclined plane. An inclined plane is a simple machine that is used to get down heavy goods or heavy commodities from the back of trucks as big vans. We use inclined planes to get heavy stuff there. So this body that is being gotten down to the back of this van has a weight, as does any body that exists under the gravitational sphere of Earth. Now, this weight also has what we call the horizontal component of its weight or its force, and then we also have the vertical component of its weight and its force. Horizontal component is always given by cos theta, and vertical component is always given by sine theta, as you can see from the diagram here. Look at different cases that apply to an inclined plane. The first case is if the body moves upward, we say that acceleration is greater than 0, and it is given by the force minus the mass times acceleration due to gravity multiplied by the sine theta, the angle of inclination, which is equal to mass times linear acceleration. Now, case 2 for an inclined plane. If the body is stationary, it does not move, like we've already established, friction is equal to 0 because the body is not moving. It also gives us force minus mass times acceleration due to gravity times sine theta. That is the vertical component of the force, which gives us mass times linear acceleration. Case 3, if the body slides down the plane. In this instance, there is movement, so we say acceleration at this point is also greater than 0. And you see the expressions, the formulas and the equations for use here. Another case is that for a body on a rough inclined plane, an inclined plane that is rough, that is not smooth, it's also calculated using the frictional force, which is equal to the coefficient of friction times the mass of the body times acceleration due to gravity. Also, our normal reaction can be given as mass times acceleration due to gravity times the vertical component of that force of that body, which is given by cos theta. And when the body moves upward, it's also given by coefficient of friction, which is tan theta, tangent. At this point, let's look at advantages of friction. Well, there are many advantages of friction. One of them is that it helps us to walk and run. Without friction, we wouldn't be able to walk, run. Friction between our feet makes walking and running possible. It also enables the gripping of belts in machines. It also enables nails to stay in the wall when you hit them with a hammer. Also on the road, it stops the tires of vehicles from slipping, which could lead to brake failure and subsequently accident. It also enables cars to stop or come to an abrupt halt when brakes are applied. Without friction, a car would not be able to stop. Alternatively, it also enables humans to use the mouse in the web. So as you're even touching the screen of your phone now, you know that without contact, the cursor would not be able to move, and you wouldn't be able to do things such as play games, options on your phone, surf the internet. That is possible because of friction between your thumb and the screen of your phone. We also have disadvantages of friction, because everything that has an advantage also has one or two disadvantages. We have about 4 of them. One is that it causes wear and tear. It causes deterioration of an object or a substance. So when you use something for a very long time, it begins to deteriorate. Look at your sandal you use in going to school. The way it was in your first term is not the same way it will be in your third term, because of wear and tear that comes as a result of friction. Number 2 is that it affects the efficiency of machine. It causes deficiency in machines. And that is why when we come to machines, we say no machine is 100% efficient. The reason for that is because some energy is lost in the process of trying to move the parts of the machine. Together with the wheels that are moving, energy is lost in the form of heat. So no machine is 100% efficient because of friction. Number 3 is that it causes a lot of energy to be consumed by the machine. And number 4 is that it causes loss of resources. There are some ways that we can reduce friction. One of them is by lubricating the surface with grease and oil. The second one is that we can use ball or rollers on wheels. The third is that we can smooth or polish the surface. And the fourth one is that we can streamline by a more efficient design or altering the initial design of that body to make it fit better. Have you ever asked yourself why the tip of an aeroplane is always pointed? This is streamlining so that it helps the aeroplane to glide through the sky and reduce air resistance, which helps it reach its destination faster. That's the end of this lesson. Thank you for joining us in this lesson. To refresh your memory on what we just discussed, please take the test that will appear on your screen.